Hi guys, today we will understand much more about electric potential and electric potential related concept. Let us define what is electric potential. It is the work done to bring a test charge from infinity to a location within the electric field is defined as electric potential. So let me take here a location A. So I want to bring a test charge. So let it be myself. I want to bring a test charge from infinity. So I am carrying the charge from infinity to all the way to a location within the electric field. Now this location A is at a distance of, let me take as this R1. So this is at a location of R1. So we define the potential at here. So that as we define potential at point A equal to 1 over 4 pi epsilon naught now Q upon R1. Now here the Q is source charge. Now whatever work I did to oppose me, since I am bringing positive charge, here the source charge is also doing work. So we will express this potential in terms of the source charge. So here there is no test charge, here capital Q goes to source charge only. Okay, now if I change the location, so let me take a location little close to the source charge. So let it location B, point B, and this is at a distance of R2 from the source charge. Now whatever the work done by me to bring this a test charge with me within the electric field at this point. Now here we define again the same potential. So we define the potential at point B, V suffix B equal to 1 over 4 pi epsilon naught, here the Q upon R2. So now this is the another location which is at a distance of R2. We know that potential is a scalar. So it means if you take anywhere in this vicinity, so different locations are having different potential values. Now here I want to define potential difference. Potential difference. I wish I would like to write that as potential difference VB minus VA. So if you can subtract these two values, VB minus VA, so we can get the potential difference. So 1 over 4 pi epsilon naught upon Q upon R2 minus 1 over 4 pi epsilon naught capital Q upon R1. So this is the expression for potential difference between these two locations. So between these two, what is the potential difference? This is the much. So this is all about the potential difference which is related to a source charge. So here this is my source charge. So let us change the source charge. Let us take some other setup. So we will understand what is the real meaning of the potential difference. Let us understand by watching this small video. So let us watch first. Now I think you might know what are these. So this is nothing but a fluorescent lamp which they are holding. This is a ordinary tube light in your language. A tube light or a fluorescent lamp. Now This fluorescent lamp is kept in this environment. Now you can see this fluorescent lamp is glowing brightly. Now, as per your knowledge, to glow this fluorescent lamp, what it is required? So, in your previous knowledge, if we can supply a source, here the source is a battery. So, if we supply a source, just like at here, so the bulb will glow. Otherwise, in your ordinary language, what you speak, we have to give the voltage we can give. But here, nothing of like that. So, how it is glowing? Where is the source? Now, let's run this video a little more. So, what are the effects we can see? Let us see that. Now, they are playing with the fluorescent lamps, and you can see the glowing of the bulbs. So, when you can touch the ground with a small bulb, now here you can see a spark is jumping from the leaves to our skin, because human body is a good conductor of electricity. Now here you can observe the metal rod, cycle hand, the bike hand, that is also carrying. So here the sparks are jumping. So let us understand what are these causes. So where is the source charge, or where is the source first of all? So these all are related to the same concept what we are going to talk about. Now if you can see, it is dark night time, so we can see the bulb glowing much more. So let us see it here. So where is the source now? Now to glow a bulb, so if you can take that at here. Now to glow a bulb, what we require? So we require potential difference, or in ordinary language we used to say that voltage we required. So potential difference units are nothing but volts. So here where is the source? So the source is these high voltage line. So here you can see they stood under high voltage line, high voltage supply. Now the huge amount of current is passing through these wires, so that creates an electric field all this environment. So that electric field having each point as a potential. Now to glow this bulb we require the potential difference. So now that potential difference is supplied by these high voltage lines. Now suppose if I take this end of the tube is at a height from the tube at here, and this end of the tube is at a height from the line, from the vertical. Now if I consider at a point, it is the V suffix B and V suffix A. Now between these 2 points there is an voltage difference. So that difference I can write as VA minus VB. So that gives to me the potential difference. So that potential difference is sufficient to glow this electric bulb. So see at here, the tube which is kept under the earth. So in this case, if I can take from the line, from the top of the line, if this is a vertical height, so this location from this line is at a distance. So because of this source, at here what exists? Electric potential exists, that I can take as an V suffix A. And if you can take at ground at here, because of the same source, if you can take, I'll take it another color. So because of the same source from at here, from this location, now the potential difference also exists at point B, V suffix B. Now there is a potential difference between these 2 points. The difference I can write as VA minus VB. So that potential difference causes to glow this bulb. So that is the reason all these things happens at here, how these tube lights are the glowing in this open environment, because the electrical high voltage line is creating an electric field in this environment. So that electric field having different locations, having different potential difference, so that causes the bulbs to glow. So if you can continue like this, so because of the potential difference only, the bulb starts to glow. So without the potential difference, all electrical appliances, it won't work. Sometimes you might observe at your house, all of a sudden the bulb glows less or the bulb glows more. That is due to, because of, used to say, because it's only because of the high voltage or low voltage. Actually it's supposed to say in terms of the high potential difference or the low potential difference. So here you can see the field is, the fluorescent tubes are the kept inside a field. So one of the photographer, he wants to see how it looks like, so he installed under these high tension lines. So here you can see, so these are the high tension lines. So because of these high tension lines, means high voltage from the generation station, so high voltage is passing, so under that electric field is created. So this electric field is having each location electric potential, and these electric bulbs are having different potential difference. Suppose if you can take this bulb and these two are having different potential difference. So that potential difference required, it is necessary to work this bulb. So this is the night view, what we can see how it looks like very brightly. So the photographer wants to how much electric field is creating by this high voltage source. So each point in the electric field, there exists electric potential. Let's see one more demonstrations. If we change the source, here Professor Walter Lewin is giving demonstration in his class, the same concept, electric potential difference. So here he is using this as source. This is the source of electric field. So this entire setup we name as Venn diagram generator. So this Venn diagram generator, it creates electric fields. Now if you can give a charge on this spherical surface, suppose, so it contains charge 10 coulombs plus charge 10 coulombs. Now it will be acts just like a positive source charge. Now because of this source, so we know that everywhere electric field is existing. Suppose if we keep a fluorescent lamp within this electric field, depends upon the location. So between, suppose if you can keep that fluorescent lamp along like this, so at the two ends, obviously potential difference exists. Now if the potential difference is existing, so the bulb will be the glow. So that is the proof that the source charge creates the electric potential. Now he is going to place the same within the electric field. So between the 2 points, the electric potential exists. Now depends upon the position how we keep, that makes the bulb to glow. Now if you bring that in a location which is close to the Venn diagram generator, now here we can see. Now as per I said, this is the source charge, electric field exists. Now this is at a location of potential V suffix A, and the same electric field all the way if we can draw, so I have to draw all the way like this. Now this is also at a location of the potential at B. Now it is having potential difference, so we know that this point is at a distance and this point is a farther distance, so obviously there is the existing of the potential difference. So that potential difference is needed to glow this electric bulb. Now if you can make it dark, yeah, you can observe that, so the fluorescent lamp is glowing in this case. So because there is the existence of the, at these two ends, existing of the potential difference. Now what happens if he turns as an equatorial point? So this point we call as an axial point along the same axis. Suppose in this case, so in this case if you can keep the fluorescent lamp like this position, so what do you expect? So the bulb will be the glows or not? Now we can see, so this location is at a distance and this location is also at the same distance, that is also at the same distance, but in the two dimensionals it looks little bigger. But when you can keep, so that equatorially the fluorescent lamp is at the same distance. Now it means they both are having at same potential. So I can say the potential in this case, potential VA equal to VB. So in this case potential, so if you can write the potential difference VA minus VB, that goes to 0. It means in this case there is no potential difference. If there is no potential difference, obviously the bulb, it won't glow. That is due to because of we kept that fluorescent lamp in an electric field such a location. So this location we call as equatorial location. So along the equatorial location, the electric potentials remains same. So that's why in this case the bulb, it won't glow at all. So if it make dark, so here you can see there is a no glowing sign of the fluorescent lamp. So even though the electric field is present, but the lamp is kept at along the equatorial location. Now let here you ask yourself, you want to increase the glowness, you want to increase the bulb to glow further. So in that case, so just like at here, So he finished the demonstrations. I will play back. To increase the glowness, so it means to increase the bulb to more bright, so what's supposed to do, there's supposed to be more current has to pass, more current has to pass through the bulb. So when the more current will be the passes, when there is a more potential difference. How can you create at here more potential difference? Suppose at here the potential due to because of the source charge, let me take as an 250 volt. So at here, so let me take that as a 220 volt. Now what is the potential difference? Now in this case the potential difference is equal to 250 volt minus 220 volt. The difference of the voltage just it is a 30 volt. So 30 volt causes very less bright, very, it is not at all sufficient for the fluorescent lamp. So to make it glow more, suppose if I made a ground connection, it means if I connect just like this, no need to connect with the wire, so just you can touch one end with your finger. So the professor used to do the same thing at there. When you connected to the ground at there, means touching one side. Now here you can see one side is a 250 volt, and at here another side, what is the voltage potential difference at here? Since it is connected to ground, it will become 0 volt. Now if you can write the potential difference, so now the potential difference I can write at here 250 volt minus 0 volt. What is the potential difference? Now it is a 250 volt. Now 250 volt is the passing, see, sorry, 250 volt is the potential difference between these 2 points. So that 250 volt is enough and more to cause more electrons to flow through the bulb. So in that case, the bulb will be the glow much brighter. So to glow, sorry, to for the fluorescent lamp to make it glow, so it requires potential difference. So that is the importance of the potential difference.